Hello, in this video I'm going to show you my line following robot and explain how it works and walk you through each part used in this robot. So, what's actually line following robot? It's an autonomous robot that follows a black line on a white surface or a white line on a black surface sometimes. It uses infrared sensors to detect, and the line is being followed by this microcontroller. This infrared sensor sends some signals to this microcontroller, and this microcontroller is programmed in such a way that it can understand those signals and follow a line effectively. The main component of this robot is this microcontroller, and the other things of this robot I will explain in brief. But in for time being, just give me a short introduction of the things. First, I will talk about the brain. The brain is the ESP32. This is a small microcontroller that will act as the main computer of this system. I'm sorry for my shaky hands. This is the this is the power system. Two LiPo batteries, 18650 cells. Each are at 3.7 volts. So at total, they are in series, so they'll supply 8 volts, around 7.4 to 8 volts at fully charged. I am using two different power supplies for this. One for driving the ESP32. This is this buck converter. This is LM256 buck converter. This steps down the voltage to 5.05 volts for this ESP32 and all the computer based system, and this is the boost converter. I am using two different why I'll tell you. I have divided the robot into two parts. One is the computer part and the other one is the motor drive system part. The motor drive system part can handle voltage up to 10 to 12 volts. The motor are themselves rated at 6 volts each, but I'm using a boost converter, and through the boost converter I'm supplying them 10 volts because they can handle it, and at low RPM, high torque, I need high voltage. That's why I'll explain it later. And the ESP32 is taking 5.05 volts from this buck converter. It doesn't matter how much voltage I am supplying it within a threshold. Under 20 volts I can supply it, but at this point I'm supplying it 7 point something volts, and the output will be capped at 5.05 volts. The amperage is also capped because this ESP32 will not draw more than 1 amp of current for the ESP32 and the sensor, and this 8-channel IR sensor both combined draw around 500 milliamps. And now let's talk about the motor drive system part. The heart of the motor drive system part is this module. This is a TB66 module. This is the TB6612 FMG module. It's a dual H-bridge IC. There are two H-bridges inbuilt in this. This is actually a very crazy one. The voltage drop across it is also very less, approximately 0.1 to 0.2 volt drop at each H-bridge, so a total of 0.4 volt drop. If I'm applying the voltage of, let's say, 10 volts, the output voltage across the BO1, you can see this one, BO1, BO2, these are the motor pins, should be around 9.6 volt. So it's actually very efficient, and it's perfectly ideal for this small kind of robots. And why I've added this switch, I'll tell. This switch disconnects the standby from the voltage rail. You can see there is a small pin standby. It disconnects this standby. You can see at this point the switch is turned off. The standby requires some voltage to turn on, and it's currently turned off. And I'll also have added a small ceramic capacitor here. The ceramic capacitor, what it does is it kills all the switching noises. This IC switches on in megahertz. So what this does is this IC suppresses all those high frequency noises in order to save this ESP32, because ESP32 is very much sensitive to high frequency switching noises. That's why that small ceramic capacitor is very important. It's, I guess, 10 nanofarad, 10 or 22 nanofarad. For this introductory part, I'll just say that this takes a voltage of 10 volts across the VM and ground. It's 10 volts from this boost converter, and then it's doing some processing, and the signals, the PWM signals are being sent from the microcontroller to this module, and through those PWM signals it decides how the left and right motor should move. This was the end of the introductory part. Now I'll explain in details about everything, and I'll also add a schematic diagram of the electronic components and how the wires are attached, where I explained all the mechanical components and the physical things, all the components. Now I'll explain how the electronic connections are made through the schematic diagram. This is a easy EDA file where I planned the robot beforehand, making it physically. This is how you do things where multiple components are involved and many electrical connections are required to be made. So first of explaining, I'll tell about the battery. The battery, I told you, it's a LiPo and it supplies voltage to two things. One is the buck converter. The buck converter steps down the voltage for the ESP, and the boost converter step up the voltage for the TB66 motor driver IC. Now let's go on the computer part, or the heart of the robot, that the ESP32 part, where you can see it's taking voltage, output positive, it's going to 5 volt positive, and the negative, output negative, that is going to the ground, and the ground is connected through the output negative to the input negative to the common ground. A common ground is very much necessary for this kind of things, where multiple components are connected through a single battery negative, where common ground should be common for every negative of every component in the computer or in the robot. Now let's, after giving it power, the IC, the connection of the IR sensor, the RLSO8, you can see there are, I have taken 10 pins, 8 pins for the IR, 8 channel IR sensor, starting from the VP, VN, 34, 35, 32 till 26. These are the 8 pins that will take the analog values from the IR sensor, that will tell the IR sensor, that will tell the the ESP where the line is. Now I have also supplied the IR sensor with voltage. It needs some voltage to work. I am taking it from 3.3 volts from the ESP32 itself, and the ground is connected to the ground of the ESP32, and all the internal grounds of the ESP32 are shorted and they are connected to the ground of this buck converter, and the buck converter's negative is connected to the common ground. This is how all the grounds are tied together. Now let's talk about the TB66. Actually, I'm not going through a script. It's all spontaneous here. That's why I might fumble a bit. And also there are a lot of noises, as you can hear in the background. Now talking about the TB66 module, here you can see each motor requires 3 pins. AO1, for the left one I'm talking about, AO1, AO2, and there is also another, that is the PWM-A. PWM will set the speed of the motor through PWM square waves. It's a duty cycle thing that I'll explain. I don't think that you will understand if I explain it right now. I'll just go over it. It controls the speed of the, just think as it's of accelerator. It controls the speed of the left motor. AO1 and AO2 control the direction in which the motor spins. Sometimes I want the motor to spin in forward direction and sometimes in backward direction. Why in backward direction, I will tell in the next video. These 2 pins are responsible for it. Same for the right motor as well. Same for the right motor. 2 pins, BO1 and BO2 for driving the right motor, and the PWMV for controlling the speed of the right motor. Okay. Now how this TB66 is getting its power? It's getting its power from this boost converter. You can see the output positive is the boost converter, is connected to pin number 24, that is VM1, that is the high voltage pin. It takes around 10 volts, I have set it, and the negative is connected to the ground. This is the ground of the boost converter, and all the ground inside the TB66 is connected to the common ground of the boost converter through this output negative pin. And this sums up our wiring diagram. If you want, you can refer to this wiring diagram and build your own robot this way. You might change a bit of things, but the overall idea will remain the same. Now also what are the other things that are not here but in the robot itself is a is a ceramic capacitor across the 5 volt, this pin, 5 volt and the ground. There is one ceramic capacitor. I have not included it here because it will make the diagram more messy, And also I have added a switch at the standby. You can see this is the standby pin, and the standby pin is going, and it's taking its voltage from this 3.3 volt rail. You just need to add a new switch here. You can do it. I didn't add a switch, but you will. Hopefully that's all. The video is already 5 minutes, and if you are still here, I'll suggest you to watch the next part, in which I will discuss about the code that I've written so that the robot will follow the line. Thank you. This was the end of the part 1.